All right, guys, welcome back. As you can see, we have a very special guest with us. We have Avery from Aptos. We're going to be talking about how to build on Aptos, why building on Aptos is important, and many other things. Avery, welcome to the show. First and foremost, how do you pronounce it correctly?
Avery is good.
Okay. So yeah, please tell us a bit about how you found Aptos, because I think most people know that it is coming from Facebook or Meta, and that is basically taking the vision that Facebook/Meta had and making it a reality, but in a permissionless, open way. So it would be very nice to hear more about your background, but also how you found Aptos and how you grew into your role.
Thanks for that. Thanks for that introduction and getting ready started. I'm excited to dive into this story. My quick background, just my history, is I was born and raised in Honolulu, Hawaii. Lived there for 18 years until I went off to college and spent 9 years at Northwestern University, my undergrad as well as my PhD in high performance computing. I spent a bunch of time at different national laboratories, including Argonne, Sandia, Los Alamos, studying some of the largest problems in computational science, like protein folding, finite element analysis, and different types of scientific simulations. Working on software such as MPI and MPIO and parallel file systems specifically. After that, I went to work at Yahoo for 4 years on a web search and doing things around analytics on website crawling and different kinds of derived data from things like domain separation to even PageRank type calculations. I also co-founded a project called Apache Giraffe at that time, which was something similar to a bulk synchronous parallel model for computing back in our days of kind of HPC, but it works for graphs specifically. And it could do things like triangle counting, matrix factorization, and other kind of cool computations. I went to work at Facebook after that in 2011 on data infrastructure with my experience kind of from Yahoo on Hadoop and other technologies related to that, like Zookeeper. And I spent the next 7 years working on a lot of greenfield things within Meta around Hive and MapReduce, Spark, distributed scaling. Some of the cool software we built operates on 500,000 plus machines today, powering exabytes of data and all the analytics for different products within Meta. In 2018, there was a new initiative around how we would build decentralized infrastructure, and the Libra project was born. I joined pretty early on and was privileged to be able to be in the early discussions around the technology choices and the path forward and what problems were we trying to solve. And the problem we we're trying to solve was really around taking all of kind of Meta's customers, which is billions of daily active users, and thinking about how they could benefit from decentralized technology with respect to asset transfer. And I think specifically remediations were the first problem we wanted to solve in that space. And so with that in mind, we started to build out a new language, a new blockchain that we felt would serve the needs of those users. Fast forward a couple more years after that, it became pretty clear that we wanted to bring this technology to a broader audience. And so kind of that's where Aptos Labs was formed in December 2021, where my co-founder Mo and I decided to kind of leave Meta and start looking at a broader mission of not just Meta's customers, but the world rather. We're very fortunate to have many of the original team members come and join us at the time, and then going forward since then. And now we're about 100 plus people. We launched our mainnet in October, and it's been a pretty amazing blast since then.
Right. And many people watching this are developers. And I'm sure they're very curious how you guys decided to build the whole system from first principles at Facebook. It's not that you took ETH and just tweaked it, because ETH was available at that point in time in 2018. You guys started from absolute scratch. So why did you do that? Because there were a lot of different projects. There was at that point also, I'm sure, all kinds of other solutions as well outside of ETH, where you could run permission-based and permissionless, all kinds of different solutions. There was R3 and Corda and other solutions. So yeah, how did you guys think about? Did you try the other solutions first before you decided to start from scratch?
The first, I think, 6 months of the team was really spent exploring the existing technologies, to your point. We looked at Bitcoin, Ethereum, looked at Cosmos a little bit, and some other, other related technologies. And we found a lot we liked, by the way. I think at the same time, we thought, it was not clear to see a path on how these technologies would scale to supporting billions of people online and kind of with instant finality. And so that's kind of where we said, look, we're going to push a little bit more towards the cutting edge. So the first thing I personally was tasked with was, how do we think about the consensus protocol and what we want to do to scale it out? And so at that point, we kind of picked we picked hot stuff as the kind of basis for our consensus protocol due to its ability to separate liveness and safety so cleanly. And then we've been taking that basis and kind of improving it since forward. And I think in our recent protocols, we've actually started to think about, from a consensus protocols point of view, how do you separate out the things that don't belong in consensus out of consensus? So specifically things like, how do you do data dissemination, like transaction? All validators eventually need to get all transactions. So taking that piece out of consensus, how do you take execution out of consensus, and then make consensus really light? Because it's still kind of a little bit amazing, but people don't kind of realize consensus is not necessarily the bottleneck of the system. It actually can be extremely fast. It's just really about a small number of messages being sent between validators to go coordinate on an ordering. And that ordering has little to do with transaction processing, as well as the kind of data, like how does transactions get to those machines over time. So a couple of those key insights led us to our design of how we thought about Aptos and how it would actually scale out the same way the cloud infrastructure does today.
Right. And looking at the consensus, for example, what kind of process did you guys take to go from idea to production? For example, we have Cardano, which is another blockchain where they do a lot of peer reviews and scientific approach and a lot of theoretical, almost academic work. Before they push it live. And then we have other communities like Ethereum, where it's more building in iteration, step by step. They launched ETH, now ETH 2.0, recently Shanghai. And how did you guys approach it, and what's your plan to build this? Because a lot of this is fully new. So how can you be sure that there is no edge case? Do you need formal verification for something like this, for formal proofs? How do you view the strategies that different projects take, and what strategy do you take?
Great question. When we were at Meta, I think it was very clear, we can't play with our user base. That those users trust Meta inherently, and to abuse that trust and technology that would be unproven and untested, I think would be a huge failing of ours. And I think we take that philosophy going forward, even into Aptos, and even more so as our responsibility to kind of protect the assets around the world. So we went a little bit extreme. I'll be honest. We spent time formally verifying the safety of the protocol with different kinds with specification languages and provers. We went out and solicited feedback from some of the top researchers in the world to try to break the protocol. We published white papers on the topic, and we also work with different auditing firms to ensure that they could not also break the protocol. Finally, we also experimentally verified everything. So we built out testing to try to mimic different types of Byzantine scenarios and see that what our theories postulated would be mimicked inside of the actual experimental data. And we run all these processes as before release. Finally, probably the last thing is really just about like great, it's a little bit boring, but good practices to development. How do you make sure that when you test things that they're done when? Like, so when you start to submit a PR, we automatically run through a series of cluster tests that verify these kind of Byzantine behaviors, look at performance metrics, and kind of stop that early on. We also have a series of networks for testing, developer network, a test net, and now we have something called a preview net within Aptos, which is kind of spun up with a bunch of different operators and mimics different types of scenarios before we deploy. So I think there's just a lot of elements that maybe seem boring, but when you put them together, they start to build up a lot of trust within the system and for the customers and developers that use it.
Also, you guys chose to create your own programming language, Move, at Facebook, which Aptos is using now as well, right? How was that process? How did you decide that the existing languages were not good enough, and what languages did you build on and were inspired by?
Right. So I think the inspiration of Move was, Ethereum in many ways. Like Ethereum had already kind of shown itself to become the first mainstream smart contracts platform, even in 2018. And looking at that, we were definitely like excited about the idea of general computation on a decentralized ledger. And how do you kind of now express a decentralized computation? And the goal would be, how do you get from ideation all the way to production as fast as possible? And so thinking from that lens, it's really about, okay, well, let's make sure that there are fewer ways for programmers to make mistakes. Let's think about how things like formal verification can make their way into a language. And the main thing is, how do you kind of co-develop a language to be easily formally verified and not to have too many open questions and too many constraints built in by the programmer. And then things like denial of service attacks and designing a language that's not general purpose, but one instead optimized for smart contracts programming, I think are some of the key design principles that separated out, what Move is from other platforms. And so I think those were kind of the basic ideas. And then, maybe finally the last point, which is even the most important, is how do you have something kind of can evolve quickly in the future? Because EVM has been used in so many different platforms, which is fantastic for that space, but it also kind of prevents the language from making rapid iteration. And so as we think about how do we advance both the blockchain and the language in tandem, the same way you think about hardware, software optimization, we kind of thought that it's very important for us to be able to take this technology forward into the future.
How do you mean that the Move is not general purpose? It's Turing complete, right? So in theory, it is general purpose, but you've made some alterations to optimize it for smart contract development. So in what ways is it optimized for smart contract development?
Right. So I think for instance, there are things that make it harder. Like we don't support dynamic dispatch, which you kind of expect for almost every general purpose programming language, but that causes a host of challenges for the proving side. As well as thinking about safety for those languages and making sure programmers get what they expect at runtime. Other things would be the concept of, for instance, high-level semantics and primitives within Move to construct like a coin as opposed to an integer to represent a coin. And then being able to put in checks to make sure that those coins aren't dropped on the floor, doubled, multiplied, exponented without proper permissions. Those are other things that you want to make sure that the language supports, so that, again, this doesn't make as much sense for general purpose programming language, but it makes a lot of sense when you think about it from an asset management perspective. So all those kind of features, plus denial of service attacks, metering, which is not necessarily, again, for general purpose languages. Even things like we have something called a paranoid mode that we added fairly recently into Move, where if the bytecode verifier misses something, we can catch it even at runtime to double check that you're going to be kept safe. Those kind of things, I think, are things that you would not expect for a general purpose programming language that make a lot of sense.
So when you mentioned dynamic dispatch and a few other things, but most importantly, you mentioned the data types. For example, if you want to do a coin, there is a data type for that already, and it is native to the programming language, right? So the compiler and the runtime themselves, they verify that all checks and balances are correct, that coins aren't created out of thin air when they shouldn't. Is that what you mean?
Yeah, so the coin itself is not native to the language. It's rather that the language can build constructs like coins, and then to verify that those constructs are upheld throughout the execution of that module is really important. And so that's something that you really can't do easily in the general purpose programming language. And even things like that are not, it has to be very deterministic for smart contracts programming language. Other general purpose programming languages are not necessarily made that way, and they don't need to be, right? That's not a constraint you want to put on them. In terms of inspiration, I did want to add also, Rust was a huge inspiration for Move. The general idea of how to push the kind of challenges of building programming, like building a program, to the earlier stages in the compile time that Rust forces you to do, as opposed to at runtime, is I think generally like something that we really liked a lot and wanted to see inside the Move programming language as well. So those are some of the other things that we were inspired by.
I'm interested in this thing you mentioned, that the language allows for this verification of constraints. For example, in a coin, I create a coin, I want everything to be verified. And on Ethereum, you do whatever you want. You have a balance function, you can code it how you can return random values if you want. It's both a blessing because it's very flexible, and there is innovation. Like for example, this like time-based transfers you can just set, and it's gonna tick from one account to another without any on-chain transactions. It's just a formula. But it's also a hell because if you're creating, let's say, an API like we do, we can never just count the transactions, incoming or outcome. We always have to check the node because the balances can change in all kinds of ways. There's rebase token where it changes based on the USD price. So and as a wallet, you cannot really protect your users because it can be a scam token which has a price but you cannot move it, or the balance is fake and so on and so forth. But so in Aptos, you make it easier for devs to work with these basic concepts like a coin. But does it also add restrictions? Is there some balance between restriction and safety? So I as a dev, can I go fully wild and create some weird coin where balances are random integer each time? Like, can you speak about that? What is the balance there between restriction and safety?
I think there's still, there are some restrictions, as I mentioned, for instance, no dynamic dispatch. And so some things might be harder from people coming from programming languages that did support that and how they write those kind of constructs in data model. There are also going to be some restrictions in terms of the language is too early, and we want to start with a smaller core of things that were useful as opposed to trying to build every single feature out there. That being said, there are features being added as there's need and as we can do it in a safe way, such as Lambda functions that were added recently to Move by Wolfgang. Those things that have kind of helped other languages kind of get faster adoption, smaller snippets of code. And so we do try to push some of these generally helpful programming paradigms into the language as it seems fit, as long as we can do it safely. So that's kind of the goal that we trade off on.
Right. Yeah, and in terms of formal verification, how would I practically do that? Because in the Ethereum ecosystem, I don't think anyone does it. You just copy paste someone else's code, then you tweak it. And in Cardano, I know they want it to be formally verified, but I haven't seen a lot of projects do that either. So how do we make it easy? Let's say that I am a dev in the Aptos ecosystem. I want to create a DEX. Like, where do I even start? Because you need normally to do that, you need to have special knowledge, right? You cannot be a normal dev and do formal verification. So how do you reason about it? Do you try to make it simpler for normal devs to do that? Most devs don't even know, I think, how to do it, where to even start. How do we get everyone to formally verify things in Web3?
Sure. So we have something called the MoveProver, and the MoveProver can allow people to write in a specifications language, different specifications they want to formally verify, of course, before they launch the contract into production. Think of it as just another form of testing, right? People write unit tests for their programs. This is just another form of testing. It's not perfect all the time, but it does provide you that kind of additional layer of security that, assuming the proof is correct, you've now put a lot of constraints on what's possible with your program. And it's up to the programmer to define those semantics that make sense for the particular program. So of course you can still build wildly crazy things and return random values if you choose to. And if you want to formally verify that you can actually return those random values, you can probably do that as well. So it's really a tool to think about how you kind of build that testing in, as opposed to kind of, everybody today, writes an amazing contract and then waits months for auditing support. And it's a one-time thing. Right. And who knows, if you add this new thing, you kind of need to re-audit, these parts of the code together, but you should be thinking about how they interact with other pieces of code. The formal verification, the specification you put into your program can kind of keep doing that automatically for you. And so while will probably replace the need for auditors, it can hopefully diminish that significantly for developers now and in the future.
Yeah, but how do you do that? Let's say a project that wants to start developing and they want to have formal verification. Would you hire someone with that specific knowledge? Is it something you hire a consultant for, like for example an auditing firm to just write it for you? And because my understanding is that you gotta be a mathematician almost, kind of, or what kind of person do you need?
I don't think it's that bad. I mean, you could take a look at some of the examples for the MoveProver, and some of them are very simple, like, how do you make sure this is not going to overflow? Or how do you make sure that only these accounts can kind of touch these resources? Those are not too hard to write up yourself from examples. You definitely could hire someone to do it. I think the interesting thing is with new LLMs like ChatGPT, we've actually been playing around with that a bit, and it does a
Interesting.
decent job of helping you to write some of the basic things for you, and then you can kind of modify and mess with them to kind of fit your individual needs. So that's another amazing tool that we've seen that could be pretty promising going forward, but in the early days.
Interesting.
But
And so in terms of how people can get started, let me share my screen here. So as you guys know, within the Moralis ecosystem, we do support Aptos in our APIs. Let me see if you see, yeah, you should see my screen now. So you can go to docs.moralis.io and you can get started here with NFT API, Coin API, Wallet API. Also, there is the aptoslabs.com where you can go and learn more about Aptos and read the white paper and get started with learning the basics. Let me see if I can share that here as well.
yeah, there's also aptosfoundation.org. That's another good one, I think.
Right. And for users, if you want to start using Aptos apps and get started, there is this Aptos ecosystem. Let me paste it here as well. Aptos.systems, where you can get started. And here we see, for example, Pontem is one of our clients. They're launching the wallet soon. Which wallet is currently the biggest one?
Oh, I don't know.
That they
We
go
have
to.
we have no favorites. You know, we love all our wallets on the Aptos ecosystem.
Right. Yeah, but you see here, guys. There's Pontem. There is
There's quite a few. There's
Future.
Quantum, Future, Martian. There's a wallet also by Aptos Labs called Petra.
Right.
Rise wallet is pretty interesting. There's quite a few. I mean, there's at least I think 15 plus wallets that are built in Aptos.
So definitely, the first step is to, when you want to develop on Aptos, is of course to use Aptos. So download the wallet, any of this, click around here, try different things. You can try this NFT Marketplace, Topaz, and other ones, and get started. So first you become a user, then go to Moralis docs.moralis.io, try out APIs, querying data, building UI, building websites with Aptos data. That's probably the easiest way to get started. And if people want to start with Move, where do you go? Because that I feel is the next. You just need basic web knowledge to build a website, and you can do that with our APIs easily if you have some Node experience or front and back end, like the traditional tech. You can build, for example, a dashboard or NFT aggregator, like all kinds of this data related things where you read from the blockchain. But let's say someone wants to start actually writing to the blockchain and creating contracts. Where would someone go to learn Move?
I think aptos.dev is a good place to get started. You can learn some of the basic concepts around Move. There's a great example of an end-to-end tutorial on how to write your kind of first applications. All those, many developers go there, and then there's the Discord. There's Twitter. There's Stack Overflow. There's a bunch of places for thinking about smart contract programming, and we also have a almost weekly or bi-weekly podcast that goes on as a Twitter space called Move Mondays. That's a great time to come in and ask your questions and learn from other devs who are building some pretty amazing things.
So if someone wants to learn Move, you think they should learn Move instantly? Let's say someone knows JavaScript, because I think most people who watch this know JavaScript and TypeScript. If they want to learn Move, should they first learn Rust, you think? Because it's a lot of resources and the tutorials and communities to learn that first and then go to Move? Or what do you think is a good pipeline to get people into Move?
I actually think starting from Move directly would be the right place to go. I think there are, like I said, Move is inspired by Rust, but it's still its own programming language. And I don't think definitely learning, Rust is its own beast to learn in many ways. High barrier to entry, but once you get in, it's pretty amazing. Move is actually, I think, much simpler than Rust in many different ways. Strange. So starting with your first Move modules, publishing those, and then you kind of start to build out some of the basic contracts and look at some of the contracts online. There's quite a few examples in different communities. Another place to go. Look at some of the different projects that are going on. There's a GitHub page. I'll just send this to you. Aptos Foundation has an ecosystems project page. So send the link somehow, but I'm not sure.
You can put it here in private chat. You see on the right.
Yeah. That's not a bad one
And
too. It kind of talks about some of the projects that are live with different websites, GitHub handles. And so from there, you can see a lot of the example code. Many of the ecosystem projects in our space have been really good about kind of honoring that open source ethos, the same way that we do. All our development is in the open. Definitely, if people want to get even more interested in the process of not just building applications, but into the way that the core devs work, there's the AIP process, and I'll send you a link to that as well, where they can propose substantial changes in the network and kind of get involved with more of.
but the very first step seems to be this Aptos move book, right? Because if you learn a new programming language, you want to start with these basic things, like, for example,
Yes,
primitive types,
yes.
basic concepts. So if you are fully new, guys, go to Aptos move book here on aptos.dev. You will see it in the menu. And then, like we just mentioned, you can go to this ecosystem projects and see different examples and view their source code. And then finally, you can get involved in the governance, right? Or in the improvement.
The core dev, if you want to start going really, really deep. So things like
right.
Move has different kinds of primitives inside of Aptos, like different kinds of cryptography that can be supported natively. And so if you want to get in that space, you could actually push further into the IP process. And this is about some of the cool things we've been doing to develop Move, going and push it forward. So what we call resource groups, a way to take those Move resources, and then how do we optimize them for the physical manifestation on storage. Is a cool thing. We've added Move objects through the IP process as well. That went live just last week, I think. So lots of cool things that you can do. One thing we did not talk about that much yet, but I do want to highlight is, as a part of the process in 2018, when we were thinking about how do we build for billions of people, one of the things that was pretty obvious at the time was the technology is going to change a lot between now and the next 10, 20, 30 years. And upgradeability has to be key and top of mind for us. You can't have a stagnant database. You have to be able to keep moving it forward to support devs when they have new design patterns or new asks, as well as new technology that comes out to get to millions or tens of millions or hundreds of millions of transactions per second. You need to be able to build out in that way. So we kind of came up with a very good process for how we do upgrades and storing a lot of that configured information on chain and allowing the chain to be kind of the source of truth for what's the latest version of the software. And every month or two, usually monthly, we've been able to do releases. And that's something that is really important for our community to know, that as we talk to developers, that new features are going to come out, really quickly into mainnet. So these asks around things like Move objects and resource groups were talked about kind of just a month ago, and now next month or two they're live, which is incredible. And that's kind of pace that we work at.
I think the big opportunity for Aptos moving ahead is really to grow the user base. And it's kind of chicken and egg, where for users you need apps, and for apps you need users. And it almost becomes that at the end of the day, something has to get users into the ecosystem. And for many projects, it's the price. Like when Solana, for example, in the last bull market, they started to go up in price a lot. That's really what motivated people to join and learn and notice it and learn about it. Now, obviously, we cannot control the price. It's up to the market. But how do you view this? Like how can we get the snowball rolling faster? And what kind of opportunities do you see in the short term for both devs to join? But devs, I feel that devs have a bit more incentive to join early, because if you are early in a new ecosystem, you build something massive. Let's say you build the kind of OpenSea of Aptos or the MetaMask of Aptos, the reward is massive. So there is incentive there. And then users need to come as well, and they come for fun things to use, trade, investment opportunities, and so on and so forth. So have you been thinking something about that, like how to get the overall snowball rolling faster on Aptos with users, devs, and how we can grow the ecosystem?
That's something we've thought about quite a bit. So when we go back again to our premise of our goal is to eventually bring on billions of people into Web3, and starting from there, what is we think the blockers are? There are a couple of blockers. One, we kind of highlighted some of the developer experiences with respect to writing smart contracts, how they do that safely, how to get it to market quickly. Another challenge has been what infrastructure can support that. Thinking about a single application like Gmail or Instagram, every blockchain in the world can't do what a single MySQL server can do today. And it requires hundreds of thousands, if not millions of servers to do a single application in the internet space of that scale. And so the technology is also a big limiting point in terms of building a very fast, scalable, decentralized database. And so that's where we think our tech is pretty differentiating as well. So first of all, developer experience. Then with respect to system characteristics, that's a big blocker. The other one finally is going to be the user experience. Yep. Right now, people onboarding through wallets, it's okay. It definitely appeals to a niche audience, but you're not going to get a billion users on the blockchain with the current experiences that exist. And so how do you build in some of those primitives at the L1 level we think are really important, not just solving them above the space. A very simple example might be something like key rotation. Not all protocols support key rotation. And so when you lose, if your key's been compromised, how do you kind of ensure that you can rotate it to protect your assets? Or it has to be this super expensive process to like transition new keys and new accounts. And then that gets confusing for people. But taking that a step further, are there interesting semi-custodial models where you typically do hold your key and you manage it, but if you lose it or you forget about it, or it gets, then there is this kind of fail-safe where a smart contract kind of manages that custody access as well to say, I can rotate your key, if you've got a good friend or you've got a bank you trust or some other entity, that entity can rotate your key if you have not transacted for a period of time on chain, and that's verifiable. It's not something willy-nilly. So there's an interesting semi-custodial model where okay, I lost my key. Now it's not a situation where I've lost every asset that I own. I can get it back after I wait some period of time, and it's provable that nothing has happened since then. And then all that happens transparently, as opposed to a lot of these things being built to help wallets being integrated earlier are off-chain, and they're not visible, and they're kind of subject to the whims of a centralized provider there. So the more I think we can do to kind of make DL1 take responsibility for building better primitives that can support user adoption from the experience side, that's something that we find to be a big differentiator as well. So these kind of things, as we build this technology across the spaces of user experience, system characteristics, and developer experience, will hopefully build a platform where developers are excited to come, users are excited to come, and not just developers of building kind of the first OpenSea marketplace equivalent or the first kind of AMM, but big enterprises also that are interested in terms of their customer bases they can trust on a platform that will scale to their needs. A good example, I think, is one of Chingari, where they've got 45 million monthly active users, and they're expecting to grow by leaps and bounds in the coming years. They're coming to Aptos because they believe this is the right technology stack for them to be able to take their user base with them as they grow. Right. And they can have the expansive creativity to build different kinds of on-chain experiences with their customer base as makes sense. Not everything makes sense to happen on-chain, but the utility that they bring, how do they connect the creators and the fans, and how do they incentivize creation, all can be done in a way that's scalable and suitable for the use cases.
What do you think about the Web2 companies coming into Web3? Like we saw with Polygon, for example. It's my view is that it is very cool that we have big names like Starbucks and others, but the use cases seems to be so limited. Some doing some NFT collections. I haven't seen anything that is truly, we're here to use Web3 to its fullest potential and not just some small gimmick. How do you view this? Do you guys have some interesting roadmap for this? I don't know how much you can disclose, but when do you think we'll see real big adoption from traditional finance or just Web2 from big tech or small tech? Like you said, Chingari is probably a good example, but what do you think is missing? Why don't we see more already? I know we have some gimmick stuff with NFTs here and there, but real things that use Web3 to the full potential.
Yeah, it's a good question. I think there's been a couple of things that are preventing it. As I mentioned, these large companies have great businesses typically already, and they have great user bases that they built up and trust from their customers over time. To take them into Web3 on technology that's either unproven or early or goes down every now and then is going to provide a big risk to their business, and I think that's a huge blocker for many corporations, and that's why they want to just dip their toes in there in many ways. And so as we start to see these kind of new cases like Chingari, and I think another one we want to talk about would be nPixel, who's built MMORPGs that have tens of millions of customers in the past. building their new products on top of Aptos and saying like, yeah, like how do we bring that utility to people? How do we build things that are not possible, in the space before on top of Aptos due to its additional capacity constraints, due to the ability of these new constructs like move objects to move forward? How do we do that? Is really key for us to have kind of these case studies at large scale, where if you see tens of millions of customers coming on board and taking advantage of these features and showing that users are getting a lot of benefit and value out of it, other large corporations will follow, and they will see that this is the future of the internet and join in.
So one part of the ecosystem are the corporations, like we mentioned, and there's a roadmap for them, like you said right now. Another part is taking the capital from ETH and other blockchains and moving into Aptos, because that's also very significant. There's a lot of transactions, capital, TVL in EVM space. So how do you guys use? Do you have some bridge that is easy to use to bridge assets back and forth? Do you also have a strategy for this audience, for existing Web3 users to come into Aptos, provide liquidity, and be part of the Aptos ecosystem? How do you think about this audience?
So there's already been a huge community that's already developed in Web3 far before we came along, and we were very appreciative of that fact. We were very fortunate also that on day one launch, partners like Wormhole and their Zero launched alongside us within hours, which was amazing. And so those are great products for thinking about bridging liquidity as well as assets from one network to another. There are quite a few other bridges that are building on top of Aptos as well, that are either coming live or are already live today. But those are the ones that I think that are driving a majority of the traffic right now.
Makes sense. So basically, if you want to bridge assets, you go to Wormhole Bridge, and you should be able to do that. And the other one you said it's easier. Sorry,
Layer Zero as well.
Layer zero makes sense. Yeah, and so assets can easily be moved. Devs can easily learn. Like we said, we have a roadmap for corporates. So what else? What else is a big opportunity that we haven't mentioned yet? You think, or you think we mentioned all of the key initiatives?
I think we mentioned the key thought process around like where we see the adoption coming from. It is going to be a combination of amazing organic growth. There's been on day one launch or within the first day or two, 30 projects came live in the Aptos ecosystem. That was incredible to see, as we'd been building for a long time, but weren't sure like how people thought about Move and the technology we build, and we were very well rewarded to see that people were excited about it. 6 months later, more than 100 projects are live today, and that's really exciting as well, and coming live, daily almost, with hundreds more winnings in the wings. We're starting to see larger products like Chingari being built and deploying to Aptos. NPixels games, which have again millions of users in the past, are going to be coming to Aptos.
Is it NPixels?
Right? NPixel, NPIXEL. They've launched a venture called Metapixel, and Metapixel is kind of under the arm doing it. But there are hundreds of people in the company who are excited about Web3 and know how to build AAA games. And excited to do as much as they can on chain when it brings utility to customers. And some of the things they propose around proof of play and others are very novel concepts. And many of the big gaming developers are watching them closely as a case study to see, what does this, what kind of value does this add to the space? How does this take gaming to the next level? And so those are just a couple of examples that we have, but there's many other products and partnerships that we're excited about. Partnerships with Google. We've worked with AWS in the past. We're starting to work with many other different enterprises around how to bring their audiences the value of Web3. And so this kind of strategy across the board is something that and then of course developing the tech to support every use case going forward is something that we're really excited about for this coming year.
Fantastic. One final topic I want to touch on before we wrap this up is about the ecosystem of Move, because you guys are not the only ones. There's also Sui, and is there someone else as well? Because it's not only you guys, right?
That's
so
right.
What's the difference, and do you work together? Is it more of competition? What's the dynamic?
Right. So there are the ecosystem partners that work on Move. I think you called out a couple of them. Starcoin's another one, and ZeroL would be another platform that uses Move. But what we've been excited to see is there's been interest from many other networks, such as Solana and Near and Avalanche, to incorporate the benefits of Move into their communities. And so, our hope is really that the community can come together as some, and agree that building a proper smart contracts language that allows that fast path from ideation to production, that supports formal verification, that supports building things simply and safely, is going to be the right platform to take us forward into the future. So we're definitely looking forward to collaborating with everybody in that space. And most of our contributions to Move go directly upstream into the Move repo.
And so everyone is collaborating, right, on the Move repo.
Yeah, that's right.
And what do you think about layer 2s? Because there's this interesting concept that if you scale layer 1, it's going to get filled up instantly anyway, because then, more arbitrage is going to be done. Let's say you scale, ETH 10 times. Okay, now arbitrage bots can do 10 times more transactions. The margins can be smaller for the opportunities you act on in the markets. Like, there's endless amount of transactions that can be made if you scale L1 that instantly fills up all the block space again. And the users who just want to, trade some coins or play a game, they're priced out again, because there's so much incentive to build this bots and flood the blockchain with financial transactions, where the initiator of the transaction actually can make a profit, and they're then fine with a higher fee. And so there's this argument that if you think about L1, it's going to be very difficult to, no matter how much you scale it, you still need L2s for use cases to be separated. So your grandma who wants to buy something like with $5 doesn't have to compete with MEV bots who can pay way higher fee. So how do you guys use it? Because I've also seen other projects like Rising say that, but we have a system which doesn't need that because we have parallel execution, this and that. So they figure it out, according to how I understand it, at least on layer 1. Do you have the same approach that your layer 1 should handle all of that? How do you view this argument and the idea of L1 scaling, L2 scaling?
I think ultimately L2s are really about how do you kind of practically solve a problem of scalability. When your L1 is not going to be able to support the use cases that your ecosystem wants. And so that's definitely one way to do it. It's a way that imposes additional user overhead in terms of trying to understand how to bridge between different assets, and also risk. Well, those bridges have typically all been hacked in the past to some degree. Our feeling is, to simplify the user journey, scaling the L1 is a better path forward. And so as we think about the design of Aptos, it's really a pipeline design. Every stage of that is designed to be parallelized as well. And you kind of alluded to the parallel transaction execution, what we do with block STM. But generally, if we have a software stack that can flow across resources available to validators, and so if a validator today has 2 CPUs or one versus one, or additional memory that can be utilized to improve performance, or more storage space, that's one way of scaling kind of vertically on a systems perspective. Another way, though, that we're really excited about is to take the same ideas of, like, you can scale up a network by adding another network to it, to L2s and more machines. Why not just have the validators scale up those machines individually? So you're scaling somewhere, right? You need to bring more resources into the network somehow. And our path and process has been about how do we take that pipeline approach, how do we make the parallelization of those pipeline stages, and then how do we apply that to the validators to scale up themselves in the same way that a cloud infrastructure might scale. So as the network demands more, the capacity can increase as validators add more machines or more hardware to their setup.
But do you agree with the statement that there's infinite demand? Because let's say that now it's cheaper to do transactions. Okay, now all the arbitrage, because blockchains are financial at the core, and so there is so much inefficiencies you can act on in the market and make a profit if you have a bot that runs. And if we scale down the fees, okay, opportunity, I can act on this 1 cent opportunity now that I couldn't do before. I can earn 1 cent here. If the transaction fee is like sub-cent, then and so the more you scale, the more transactions are just gonna come from this financial inefficiency arbitrage bots. So do you agree that will price out everyone else, that it will make it impractical, or do you not agree with it? Because I'm still not sure what I think.
I think there are some limits, as you mentioned, when it comes to like MEV. It's hard, right? Because you're right, taken to its extreme, like as long as there's a profit to be made, people will drive transactions to the system to a large extent. Now in practice, I don't think we've seen that yet in many ways. Like, we have, for instance, in Aptos, there's tons of capacity that's unused today. And that's why the execution fees are basically zero today. As long as you don't hit that capacity, execution costs are none, because the system is not doing much anyway. You're just kind of paying for a little bit of networking, and if you access storage, then yeah, there's a storage fee. But by and large, if whether you rent a AWS instance for an hour and you use all the CPU or not, it doesn't affect the cost. And so as long as those kind of core costs can be met by validators, that's the lowest kind of price point at which fees can sit on the network. Unless there's other incentives to kind of incentivize, like other methods of incentivization that produce maybe more complex economical models. So in general, I think we would agree that for MEV type optimization, there may be cases in which those get pushed to other networks or off chain. But from a practical, realistic standpoint today, that's not the case. And if we can push the barrier, like keep the capacity so far in advance of the demand, may not practically be a problem.
Makes sense. Avery, it's been a fantastic time speaking to you. What have we missed? Is there some big topic you've just been waiting for me to ask about, but we haven't done yet? What more should people know about Aptos?
I think our hope is that people understand that the goal of Aptos is really about how do we bring the utility of Web3 forward for everyone. And so, we're excited about the fact when, we build technology and other networks adopt it, by the way. That's happened a couple of times. We're excited about, other networks doing well as well. We're looking to make a difference as a part of this space. And we're one community, right? So all our code's open source. Feel free for others to, I think some have taken advantage of block STM, some have taken advantage of some of our consensus primitives. We love that. Like some people might think of it as competitive. We hope that more people adopt Move. Like that's a great thing for our ecosystem in general. And so as we kind of keep developing and pushing forward with this technology stack, just kind of remembering that we're all in this together, and that at the end of the day we all win if there's a mass adoption of this technology that can bring benefits to society. That's our goal, and we hope that we see that happen as soon as possible.
That's a great message. And thanks a lot for tuning in, everyone. Smash up the like, check all the links in the description. We will link to all the key Aptos resources. Thanks, Avery, for joining us this fantastic Friday. And if you have any questions, guys, put them in the comment section, and we may do another follow-up. Let's see. It's all about what you guys have in mind in terms of follow-up videos. So let us know in the comment section. And thanks again, Avery, and goodbye, guys. Goodbye.